In my last session, which was quite a while ago, I talked about some security aspects. How can you get into containers and how can you do code around on container security? Today, I'm going to talk more about the importance of data protection. And a lot of our stuff that is with the modernization is running on cloud. So as consumers to the cloud, we have evolved a lot and we have adopted cloud to a very large extent because we wanted elasticity and all of that. And very recently, generative AI or some form of AI has started spinning up. And what AI needs to perform, there is a buzzword about AI and ML. People use it as AI and ML, although AI and ML, though AI is built on top of ML, which requires basically data for machine learning, and then machine is able to artificially make decisions and do things. That's what we call AI, right? So the need for data is very, very high. So all the systems are pretty hungry for data, and all the data is sitting there on the cloud. So it becomes very, very important for us to talk about the importance of data and how do we secure it and how do we work on solving it in the system, right? And we take care of that. On the screen, you can see two of the very, very recent breaches where crawl employees swim swapped happened and the people's crypto data were compromised. A lot of people have got breaches on that. And then there is a 16 shop which is actually running a phishing service, phishing as a service platform. So imagine the level that it goes to. It is not only talking about trying and doing attacks, but it is also providing attacking platforms or platforms from where you can do phishing and other kind of security vulnerability activities can be actually launched. Very very steep increase in the number of people, number of companies have been there who have reported a lot of ransomware attacks, reputational damages being caused because of security breaches. The trust and the functioning of the system are taken for a toss. So those are very important aspects that we actually need to hold when we are running our business. So we need to really focus on our data and how do we safeguard that data. With what has changed for us in the cloud, the evolution that has happened in the cloud is AI has started transforming a lot of things. If we go back to the level where people were creating Excel files, people were creating data as simple as CSV to a spreadsheet, or people were creating mail merge documents, and all of those all have been transformed very, very fast. Nowadays, you can find like dozens of people who are preaching and teaching you how to do prompt engineering. A different stream of skill has already come up, which is called as prompt engineering. So how are you going to tell AI what to do now? The most important aspect of that is that you give AI the context and you tell AI to do whatever it is, right? So when you have the context being given to AI, then AI tries to put itself in that shoes, and to put it in that shoes, it requires all the lot of data based on which it can understand, it can start making decisions or start making trends of what it would be like making a decision with those contexts, which means AI has led to a hunger of vast data sets, and those vast data sets are stored in cloud because those are scalable and those are accessible. So what is needed is one entry point and all of that data is available to the AI. It may not do a damage the very day the access is leaked. It may do a damage over the time when the data has been pumped and has been used to its skill development by AI, right? So our focus today is to ensure the security of data in the cloud environments, specifically when it comes to AI, right? And yeah, there are some of these crackers in between. You can read for yourself. Take a smile. Security doesn't need to be serious all the time. Now talking about major data security vulnerabilities, there are vulnerabilities around that gets exploited due to misconfigured access controls, weak authentication systems, insider threats, or data transfer vulnerabilities. So it is very common for observation. If you see the programmers who are doing the programming, they would actually go ahead and create a service account, and the service account will have all the sysadmin and server admin level permission and use that account. That is an example of a misconfigured access control. Then weak authentication. It is very easy to use basic authentication, username, passwords. And if you talk to people who are developing these small softwares or trying to make some automation for a very small piece of functionality in an organization, there is huge amount of inclination to rely on the concept that since this user is logged in, or we are in the organizational network, this user must be logged in or would be a valid user. So I don't need to go and do authentication for him. Or assuming that my database is very, very safe and secure. So when I'm devising this application, username password is actually stored in the DB. So nobody can get it through there, and the breaches cannot happen. I am very sure that humans doing packet sniffing probably would be safer for the data as compared to AI doing the packet sniffing, right? So if I go about imagining somebody telling a tool that consider that you are an expert to network packet monitoring, and using this particular tool, just go ahead and tell me what is the encrypted data that is being transmitted over the wire, and use some kind of Wireshark or some kind of other tool, APIs to get that in. Those could lead to very great observational outputs and can lead to those kind of information. So it should be made sure that all the authentication requirements being done should be kind of very, very secure mechanisms like Azure ADs, like Okta integrations, or some kind of SSO logins, and not leave them to regular authentication mechanisms like basic authentication and stuff, right? Then insider threats and accidental data exposure. In the time where we have got very thin lines between the personal and the professional, a lot of the organizational employees and people, they are all operating on the set of data that sits on their mobile devices or their handheld devices or portable devices, and a part of their life also runs on the same. It doesn't take more than fractions of seconds for somebody to mix up between their personal OneDrive and the official OneDrive. There are various provisions to make sure that this doesn't happen, but the insider threat is that kind of a thing where an employee or an insider to the organization actually compromises on those kind of behaviors or is accidentally exposing out some sort of data. It could also be an example where I know that some organization in the past has suffered this. a developer was as simple as launching a VM. He attached a IP address, public IP address, because he wanted to connect and work on that. And that public IP address, when he was attaching it, he never had the security group before attaching the public IP to the instance to restrict to any IP range. So when he attached the public IP, it was widely open for all. And there are scanners across all these mischievous elements who are scanning on for port 22s and 3389s, which are RDP ports and all those kind of things. So they get into it. Once they get into it, they have their way to the account, and everything in the AWS account or in their Azure subscription is on their access, right? So they can do way lot than we can even imagine to do. Now, the last one is data transfer vulnerabilities, which I think we all have to do, the data transfer. And so we need to be sure about how are we transferring our data. So analogies are not perfect. I've been told that, but I'll still go ahead and give you an analogy. Let's say I have certain amount of cash to be taken out from a bank and deposited in some other bank account. So it is the same kind of operation that you're taking data from one store and going and putting into another store or into another factory for processing. And the line between that store to that factory or store to the other store, it is, if it is plain, then everybody can see what you're taking. You would definitely want to mask it out when you're taking the cash, right? So similarly, you would want to mask it out when you're taking your data, to make sure that your data is not known to the public about what data you're carrying, and people can actually take data out of it. So it is basically unencrypted data, if taken in transit, if being transferred, has got a very, very prone mechanism to do that. And with AI coming up, it becomes even more that these would be sniffed much faster than what earlier could be. Now, AI and data vulnerability. There is the interesting part that I find is we have all the AI systems coming up in the place which will do a lot of things, and they need a lot of data. But when we try to use AI for the security purposes, the irony is AI can only learn from what has already happened. So we will have to give data of the breaches to AI to be able to go ahead and find out that these are the possible breaches. Now, it has to be way enough that AI can do the modeling for what all other possible breaches can be. So data breaches are only, more and more data breaches will lead to better and better AI security systems. So that is like one of the stuff that we need to understand, that till the time we get our AI security systems up to that, we will have to play the role of protecting our data, right? So it is one of the comments that I had got once I was discussing about that with AI coming up, there are a lot of chances of exploiting a lot of areas which were earlier less prone, because a huge amount of processing can be done and all of that. So the comment was, why can't we use AI for the security system? Now we can use AI for the security system, but those models would only be as good as the number of breaches they know. So all the breaches to be fed into an AI system, and then tell them that you start innovating on top of that, what other more breaches can be, and then start doing it, which I think we have already got a lot of WAF rules and rate detections and OWASP top 10 and those kind of things, which are very, very predictive. Not AI level, but they are very, very predictive for us to be able to combat and fight that as of now. And then we keep on feeding that data to our AI systems. We keep on scanning our systems for the findings and keep feeding that data for the AI to give us the options around that. Now, this is about how AI and cloud and data are going hand in hand. I'll like to talk about the strategies that we can imply for data protection. Um, the data is in three stages primarily. One, it is in a resting state. Second, it is in transit state. And third, it is under some secure mechanism, it is being secured. So as an archive, as a backup, and what all not, right? So the strategy that we have for data to be protected is encrypt it at rest and safeguard the stored data. Encrypt it in transit and ensure the secure data movement. Use multi-factor authentications for the kind of login and kind of authentication mechanisms that we want to use, right? So that is our strategy. Now, when we want to imply that strategy, how does the current existing cloud platforms help us in achieving those strategies? Talking about Azure. Azure provides us Azure AD for centralized identity management, which means it will be all of a SSO enabled model. There is a centralized authentication mechanism. You have MFA and all along with. So you do not rely on a system which is prone to vulnerabilities, but it is a dedicated system which is for identity management that should be used for all purposes of authentication. The keys and the encryption material that is created during the creation of a VM, during the creation of any kind of data to be encrypted and all that, we have a dedicated Azure key vault that is stored, that is available to store that. It is a secure key storage, and in spite of somebody getting into the subscription, he will not have direct access to the key vault unless he is explicitly assigned to have those kind of accesses, right? And then Azure also provides a security center for continuous monitoring of anything that is suspicious. So those kind of events can be enabled, and those kind of events can be streamed for alerts. And so that kind of a continuous monitoring and alerting system can be very easily built with Azure Security Center, and that enables a lot of alarms, proactive alarms. Those could be verified with the existing stuff. And then if we can source those kind of logs and information to something like maybe a Splunk AI system or some other AI system, then instead of having somebody to go and write a rule to find out what has gone wrong and what is an alert and what is not an alert, there are models which tell you about black swans, which tell you about events that have never happened before, or tell you about events that are related to protected or secured assets. Those can be flagged, and the speed of detection for the same can be really increased and enhanced. So that's one area it works on. Coming to the next part of it, Azure provides confidential computing. This enables hardware level encryption. So even in untrusted environments, your data is actually being processed on hardwares which are basically having the encryption mechanism on themselves, right? So for applications which are finance, healthcare, research, so there isn't a chance of a breach while having the process going on, right? So that is one of the best services that can be used here, right? Similarly, we have features available, made available by AWS. AWS provides you IAM for the access control, which is AWS backbone of security system. Then they also provide KMS for the centralized key management. It is very much like Azure Vault service. AWS key management store, where users are able to bring their own keys, are able to create keys by AWS, and they call it as customer managed keys and Azure provided keys and those kind of things. And then AWS CloudTrail enables event logging, event capturing, and monitoring. And based on that, it tells a lot of information around the AWS events that are happening, and the same can be streamed to CloudWatch for the kind of detection and alarming purposes. There is also the popular storage system S3 of Amazon, which provides encryption level storage, storage level encryption with AES-256, or the keys that are stored in AWS KMS, and the in-transit data can be encrypted using SSL and TLS encryption. While I have used the word SSL, please be aware that SSL is now a vulnerable protocol and it's not used. We only use TLS, and the recommended version is 1.2 and plus. 1.2 is also 1.1 is also considered to be a deprecated one. And then the hardware level security by AWS Cloud HSM is the dedicated hardware security, where all of the processing that is happening on hardware level encryption, so that the data during the processing cannot be compromised by any of the processors or shared mode processing devices. And that gives you one packed system for data processing in a secured and encrypted manner. So while we have this, let's see that few case studies that has happened in detail about the data breaches. These are some good ones and big ones. Capital One data breach. I'm hopeful that some of you may already know about it. It is Capital One is a bank, right? And one of the former employees exploited a vulnerability in the web application firewall. So what is to be noted here is we have web application firewall already in place, right? So it's not an application which is exposed, right? And then with knowing that XYZ amount of rules are enabled, there are other rules which are not enabled. This is exploited, and unauthorized access to sensitive data was taken. Around 100 million customers' data were compromised, including their SSNs and the bank account details, which was a huge thing, right? So what we actually learn out of it, what the story tells around, if you see the cause for it, right? So it is because there is an access control that was compromised, that was not in the most desired state of it. Anybody who is a former employee should be deactivated from all the angles immediately. Accounts and access and authorizations all should be. But if we are using something like basic authentication, then there are fair chances that that particular authentication mechanism is credentials are exposed or known or being written down. I have seen multitudes of users who use Java or who use non-Microsoft based programming languages. They tend to use basic authentication or databases like SQL Server or Oracle, because the thin drivers are very, very comfortable with those kind of credentials and authentication. But we need to understand that the pain of getting that one service account is for once, and once it is solved, it is available and you can keep on using it as many times as you want. But having a basic authentication once created, it carries on through the software life cycle, and it's very hard going around to kill all the dependencies even when we want to remove or switch to the newer mechanism. So we should definitely put it as a practice from our development stage itself and not have to go back to find out that we have to eliminate some of those. Now, regular security assessments and audits. If there was a periodic audit on things happening, I think this should have been, this could have been uncovered, and our assessment should be very, very extensive in terms of the coverages. They should not be based on what we have implemented, but they should be based on what we should have implemented based on the upcoming vulnerabilities and kind of incidents happening in the industry, rather than confining the knowledge and information from within the system. So it has also been seen that a lot of security and audit assessments are inward focusing. They do not take a lot of information or learnings from outside unless there is an external audit agency involved. So if it means, if it needs to have an external audit agency involved, then we should do it, if that is the way to have external or the recent incidents and that information to be included in our audit purposes. Our audit should not be a rerun of what we did last time. There should be addition to what we have added and plus what we have done last time. So that is very, very important. Our audits need to be progressive, right? Then continuous monitoring can help detect and respond to anomaly promptly. We are almost there. Almost all of our systems are being monitored by design these days. They are being monitored for the uptime. They are being monitored for the business availability. They are not being monitored for any kind of security incidents or any kind of secure asset access from unauthorized sources, or any kind of API keys and stuff that have that are beyond their role, beyond their life of rotation, and those kind of things. For example, there is an API key which is running for last 90 days, which should have been rotated by now. If not being rotated, it's not being monitored. So that's one of the other area that that we should add to, and those kind of security incident monitoring, security possibilities, secure and insecure practices should be monitored. Former employees' access should be promptly revoked upon departure. So that one, last one is very, very specific to this particular case, but others are also coming out from this. We also came across another scenario. There was one other big breach. Tesla's unsecured S3 bucket. Do I have a raise of hands? Anybody of us know about this one? So we had a lot of data sitting in S3 about Tesla's vehicles telemetry. So there is a lot of AI training that was happening. The vehicles being able to detect, vehicles not being able to detect. It was all lying in Amazon S3 bucket, and that was unsecured. And it was also to the level that it was accessible outside. So the storage settings were kind of jeopardized, and it made it accessible to whole of the world. And S3 buckets being accessible, there are multiple vulnerability types that can happen beyond data also. It could be a financial loss as well when S3 buckets are being exposed. Mere exposing a S3 bucket can cause us a lot of financial value if a user is accessing a particular object on a very high frequency, on a very high rate. So our S3 bucket should be blanketed, as in no bucket in the organization will ever be public. It is one of the practices that we should follow. And when we need to source that data to some system or some kind of client or a partner, then we should find out how do we want to do that, and it should be an explicit way of giving access to that particular set of group only, right? So let's talk about this scenario here. The incident was about sensitive data with vehicle telemetry and AI training data on an unsecured S3 bucket. The risks that happened was storage settings were misconfigured, leading to unauthorized access. What we found is the cloud storage settings is paramount. So in the start that we talked about, we went to the cloud because we wanted elasticity. But with elasticity also, we have to enforce discipline so that we just do not have things elastic and out of control. We need to have them being done in the proper way. Proper DevOps practices have to be implemented. And that is why that term has got its evolution from DevOps to DevSecOps. And all of the things that we are doing in the cloud, we should all be doing by using pipelines, automations, and stuff, not by ClickOps. There is a huge discouragement being done to the ClickOps practices. We should be doing all of those by using our pipelines and stuff. Now, regular security assessments are essential. That we talked in a last scenario also about the auditing parts. Data exposure risks can be mitigated. In this particular case, there was the data that was leaked was vehicle telemetry, but it could have been bad if it was a data something like the Capital One's bank accounts, SSNs, or other kind of sensitive data for the users. So we should be just trying to make sure that the data and the storage structure that we have used, those are properly guarded with access. Beyond this, we also need to make sure that our data is safeguarded on the storage layer. So if at all for any other reason there is a breach and there is an access that is available, but still the storage layer should be encrypted in such a way that we need to have the key to be able to access or read the data from that storage layer. We'll talk about that in our coming slides. So let's talk about some of the best practices for data protection. The most neglected part of data protection is the backups and the DR plans. We try to transfer data from one region to another region for disaster recovery plans. We take backups and we often miss encrypting them, or we do not actually see that there is a need for backup to happen, or there is a need for some kind of encryption that needs to happen on the layer. So regular backups and ensuring that the backups are also encrypted, then continuous monitoring for any kind of unusual activity, educating employees about the risks are the best practices around on data protection. Now, coming down to three other areas of data protection when we are talking about architecturally, there is something called as last mile encryption. So, and encryption at rest, and third one is encryption in transit. So those are the three areas that we will talk about. Last mile encryption specifically focuses on any kind of data that is being transferred between the client and the server. There are architectural designs where we host our data on a VM. We put a load balancer in front of the VM, and we put the VMs, the load balancer's CNAME on the DNS and make it accessible for end users to access. This particular load balancer would have a listener which is running on HTTPS or TLS 1.1, 1.2, and we have a certificate, and things are being transferred in secure mechanism. However, the part of from the load balancer to the VM traffic is left onto the configurations or the security being provided by the cloud provider. Though cloud providers claim that this layer is also secure and nobody other than the user who has access to this subscription can ever know what is going on. But point that is very importantly to be noted is the data between the load balancer and the VM is actually unencrypted. This part of encryption needs to be made sure that it is working fine and it is done properly. So the termination of HTTPS or certificate, TLS certificate, should happen on the machine, not in the midway. And if it is happening midway, then there should be a handshake on the device so that the data is re-encrypted and being passed on to the VM in that way, right? So encryption all the way till the client before sending it to the cloud, and after it is originating from the VM or the client or the storage layer to the client, both sides of encryption from end to end, that is very, very important. So we must be having all sorts of secure communication. When it comes to API, we can use HTTPS for REST APIs. We can use gRPC. We should be using all sorts of secure communication only over on secure channel. We shouldn't be using insecure communication mechanisms anymore. LDAP, please use ldap-s. Do not use LDAP queries or LDAP ports. So for every communication that we do, whether we do FTP, whether we do HTTP, whether we do LDAP, there for all of them there is a secure mechanism. Even for database connection, there are server secure, certificate based encryptions that happen on the transport layer. Please try to configure and use them. If you are not using, just try and create that startup kit. You can also find those in some of my upcoming lectures where I will demonstrate some of them 101, that this is how we go and achieve that, and that can work as a starter for your upcoming projects. Coming to the encryption at rest, the data to be classified, whatever data we are storing, whether that data is a textual data, whether that data is a PI data, whether that data is a PCI data. So we need to classify the data, and based on the classification of data, we need to select what kind of a storage that we give, and then based on the type of storage, we encrypt them using either key vault keys or KMS keys based on which provider we are running on. For all the data that is sitting on the VMs or EC2s, we are using disks, EBS volumes, managed disks. We must be having those disks created as encrypted disk by default. I have seen loads and loads of Terraform scripts, but none of them really talk about encrypted volumes in the first place. So everybody who is learning Terraform, I recommend that your first Terraform script, which says that create a VM, in the section where you are going to create your managed disk, encryption should be by default turned on. That is how we should be using, unless we have a reason for not encrypting something. That is the level of safety we want, security we want. On our machines, on our laptops, we get our laptops which are PGP encrypted. Why would we create a VM which is actually not having any kind of disk encryption and store data in plain text? So just keep that analogy and try and be very, very sure about that your storage layer is encrypted. Coming to databases, we should have transparent data encryptions on. We should have server-side encryptions on for storage services like S3s and all, and AES 256-bit encryption for backups and virtual machine disks is highly recommended. So encryption at rest needs to be encrypted, whether it is a snapshot, whether it is a backup, whether it is a dump, whether it is a running disk, managed disk, whatever kind of storage we are putting in, it is a S3 or it is a logical volume on Linux, we should be making sure that our data at rest is purely encrypted. And now basis on if it is a PCI or PII data, then that data needs to be encrypted on the record level or on the basis of attribute and value level of encryption, basis on what kind of sensitivity of that data is. So the storage layer is by default encrypted, the record level gets encrypted, and the column level gets encrypted basis on the criticality of the data. So even if the storage layer is compromised by the way of getting access to the key, the next layer of encryption is in the play, and that should stop people from getting that particular data, right? So it is very, very important to classify and identify the storage encryption policy that you'd want to apply on it and make it as an organizational policy or a project policy for implementation. Coming to encryption in transit, always use secure protocols. Use HTTPS TLS for transmissions. Certificate management should be always done with trusted authorities. One of the popular trusted authorities these days is Latest Encrypt. The challenge that I've seen with Latest Encrypt implementation by developers is there is a need to validate the certificate usage, and if the certificate is not used over a particular time or is not renewed after that 3 months of time frame, it gets expired and your application may have insecure or expired certificates or certificates which are not valid. So your implementation, while it focuses on being frugal, it should have the details of automation to be able to automatically renew those certificates over on the time and get that particular thing, have that particular thing up and running all the time. Azure application gateways or AWS ELBs or AWS ALBs terminate the SSL connection at the edge for secure communication. Use security groups, network security groups, and block all the IPs that are not required and only grant access to those IPs which are required. So follow the least privilege model, least privilege required model. You should go ahead and deny all and allow or grant access to specific rules where it is required. That helps us to stay in check on what we are trying to expose our data, who all we are trying to expose our data, and whom we are giving to. Otherwise, it is basically a chase to find out who all is accessing our data without our knowledge even, right? So this is primarily the gist of all those 3 things that we need to do. Going to future trends, AI-driven security for early threat detection, we are getting there. Then homomorphic encryption for secure computations, and evolving regulations shaping data security practices. I'll talk about all 3 of them one by one. So AI-driven security, as we peer into the crystal ball of data protection, there is a huge possibility of AI taking that role, and there are a lot of tools and players who have stepped in to give a lot of details around these, our sonar source, our Splunks, those kind of tools which are static code analysis tools and vulnerability detection tools. They at the very early stage of development are able to tell us probable areas of fixes required, and we should take that. And then Splunk and their own AI models, those kind of tools have enabled a lot of log processing on AI basis, which give us a lot of insights in the real time, rather, to be able to detect fast and act fast. So those are the things, but I think it is still more time, more data required for AI to become even more matured and proficient. Till the time we do better system implementations, and the models will get better as and when the data is made available to them, right? So coming to the next one, homomorphic encryption. This is about processing data without having to see what the data is. So while we talked about our storage layer is encrypted, we talked about our rows and columns and attributes are encrypted. It would be great to do the processing even without converting them to the plain text level. So the hardware level encryption plus the data layer encryption and encrypted data processing in itself is one of the great ways how we can actually encrypt everything, but not have to do a lot of work in encrypting, decrypting, or worry about what can go otherwise. I also strongly feel that with quantum computing coming up, where we have qubits and we can do some thousands and million year of processing in some minutes and hours, we should be the giants would be definitely looking towards, tech giants would be definitely looking towards how we can process our data in the encrypted state itself and not have to go all the way to decipher it and then process it and recipher it back. Okay. The regulations part, there are stricter data protection laws like GDPR, CCPA. Those are getting talked about and implemented, creating a greater accountability and transparency. So not everyone is going to store everyone's data unless until needed. I don't know if by that time everyone's data will already be there. Only new generation will not probably have their data there, but the speed of data collection is very, very high. Session correlation and all of that is very high, but the assumption is with these stricter data regulations, the risk rating for the websites in terms of collecting and storing the data and their accountability to retain and make sure that the data is secure would be higher and would hence lead to lower collection practices and hence lead to lower chances of privacy breaches in instances of breaches though. So it is really important to keep a tab on what is happening in the regulations space for data collection and reduce the number of PII data or PCI data. Leave the PCI data with the payment processors and carry on and check with reference numbers and those possible, instead of having all the data sitting with your own sites. That's also because of PCI DSS compliance rules and regulations, right? So the expectation around this is that the stricter and better rules will lead to a lesser amount of data storage, leading to better data ethics and compliance strategies. Yeah, I think precisely those are the topics that I have to talk about. The key takeaway is data protection is paramount. Cloud security measures are crucial. And all we need to do is to stay updated on the security trends and get them updated. I'll take the bigger pause here and open the floor for Q&A, or over to Gavaskar.
Yeah, participants, if you have any questions, you can ask now. You are an unmute. You can unmute yourself and you can ask the questions. Yeah, one question in chat. Probably AI will speed up the detection and monitoring and reporting in real time versus done manually. Yeah.
Can you repeat that one for me?
Probably AI will speed up the detection and monitoring and reporting in real time versus done manually.
Yeah, so the reporting part in the real time, so we don't call that as reporting, we call that as more like alerting. And I strongly believe that yes, we would be on a stage where AI with better exposure to data would be in a state where it can detect that what are the securables, and if there are agents who are not authorized to access those securables, or the way they are not supposed to be accessed, if that is happening, then that would be alerted. And it doesn't stops there only. There will be the second stage of it, which will also say that there should be an action taken around that, and that would be blocked. There is a lot of implementation of that I still see in aquasec product, and this is from like couple of years back. aquasec has container security systems which do not allow you running anything that is not whitelisted in the set of operations that you perform. So yes, that is fairly possible, and that's a good thing where the security and the developers both will be in the seat of defining what is an expected action, what is an expected operation, and what should not be allowed. Basis on that, yes, the alerting and things can be done. As far as reporting is concerned, it is something that is a requirement, human-driven requirement. AI would certainly make those operations easier. I still think that that will remain in the hands of humans to be done either by using AI or by using a self-service.
Participants, any more questions? So let me move to the certification desk. So participants, the speaker code for downloading the certificate is 427380. Again, I will repeat 427380. The link to download the certificate is already provided in the chat. So let me provide a demo on that. So this is a link which is provided already in the chat. Just you can click that link and it will be taken to the home page of that particular session. And now you can register as a guest. You can provide your name, your email ID, your phone number, and and you can provide organization details, and you can click register. Yeah. Now it will ask for find certificate option. Just you click this, and now you can provide again. You can provide your details, your name to be printed in the certificate, your email ID, and now you can provide the secret code over there, and you can download the certificate. Okay, that's all from the certificate desk. Hope you enjoyed your session. Any more questions? So, Deepak Singh, we can wind up the session, I think. Yeah.
Thank you. Yeah.
So, on behalf of Multi-Cloud cloudQ, we'd like to thank Deepak Singh for giving an excellent session on security in cloud, and he has linked the security with the current AI trend. And I hope all the participants enjoyed the session. Thank you. Have a good day.